The most important lesson in the e-course Safety Analysis in the Process Industry is Lesson 7B, the HAZOP meeting documentation. In addition to this video, Lesson 7B Part 1, there will be Lesson 7B Parts 2 and 3. Each video will explain step by step the PHA or Process Hazard Analysis, the HAZOP format, explaining each input document required. The what if PHA is very similar, but will not be part of this video. It is covered in the Lesson 7 hard copy document. It is suggested that the Lesson 7 hard copy first be read and understood and then watch these videos. It will then be more self-explanatory. The software used throughout this course for HAZOP documentation reporting was developed by the author using Microsoft Word and interactive spreadsheets from Excel. A password-protected copy can be purchased from the address in the contact list of the course. It allows access to all the cells which can be modified in the spreadsheets, except for the risk matrix risk ranking. These videos are intended to walk you through the complete HAZOP process analysis documentation, from the capture of the meeting details to the final report. The video is hosted by the HAZOP facilitator. We start with, as we said, video lesson 7B part 1, and we move to slide 1. The first spreadsheet of our HAZOP documentation is the attendance register. This is a copy of the spreadsheet that is handed out at the beginning of the meeting and subsequent meetings, and as can be seen, it notifies the participants what the project name is, the date, and what they fill in is their name, their company, their designation or what they do at that company, their telephone number, and probably their email address. This is an important spreadsheet because it documents who was at the meeting, and if the HAZOP facilitator or consultant wishes to contact any one of these members at a later stage, he can do so having this copy. It is also then included in the HAZOP documentation. Now here we have the PNID for this HAZOP, and as we described to you, we can select or choose the node or nodes for the HAZOP in the meeting or outside of the meeting. I think to save time, it's better to allow the HAZOP facilitator or chairman and the process engineer to draw up the nodes before the meeting, and these will be included in the TOR, which will be distributed to all the participants before the meeting. Of course, it can be done during the meeting, as we're doing now, and we can just choose node 1, and we'll describe it as such. And here you can see we are showing the ULSD coming in to tank 2 and then going to the pumps. Tank T1 and T2 are not shown fully because they were the subject of a previous HAZOP and therefore are complete as such. They will have vents and overflow protection, etc., etc. What we're doing in this HAZOP is the inclusion of TRVs, the thermal relief valves, and we set them at 15 bar G for argument's sake. The reason for these thermal relief valves is that if we have a section of line, typically like this here, it can be closed in by that valve and that valve. It can be a very long length of line, we don't know. The only way we'll know the length is by looking at the three-dimensional model or the isometric drawings of this unit and see what the length is. Usually, if it's a substantial above ground section, it can, during the heat of the day, build up a great deal of pressure, and if it reaches the design pressure of the pipe and exceeds it, it can rupture. So therefore we set the TRV at a pressure below the design pressure of that piece of pipe. If it does reach that pressure, the valve opens, this valve opens, and the fluid runs, or the ULSD runs through this line from the line in question that's being pressurized. It'll go through the valve, the relief valve, along this line and into the tank and be relieved. Likewise, we've got the other TRVs also with sections of line which can be shut in and therefore are protection for these sections of line. This node will then be carried through onto our documentation, and that is the next slide. On this slide, you will see that we have the PNID number, the project title, and we also have the node description. As we described or noted in the previous PNID, there is the node description that we've chosen. The design intent is important. In other words, what are we trying to do? We are transferring ULSD to the storage tanks, and that is put in there. Also, we go down the list for node 1, and this is node 1 over here. We can, if we had another node, we could put in a node 2, and we can repeat this form in subsequent pages. However, we've only got one node, so we'll only be considering this one node. This form here lists the possible deviations as a hazardous checklist. In other words, the team now look at the various parameters and guide words, starting with, say, no flow. They decide, is there a possibility of no flow? Yes or no. If yes, you put the X in the column under yes. Likewise, we move right down through the listing and we put an X wherever we believe that the parameter will be present in that node. Likewise, less flow and more velocity are ticked with an X in the yes column. Once you choose a yes, the reference number over here is automatically carried through into the record form, which will be shown in the next video. However, if there is not a parameter like typically reverse flow, we put an X in the no column. And so we go down and complete this whole form. There are parameters and guide words that we've not included, typically are used in batch processes, like, for example, we could have something like in addition to, which is not really relevant in a continuous process, but mostly in batch processes, and we won't consider them here. So this is how we fill in the possible deviation form.